Okay, this week we're doing wave function. So just noting something, k squared sine squared alpha plus k squared cos squared alpha. We pull the common factor of k squared out, we get k squared bracket sine squared alpha plus cos squared alpha. That's 1, which means we're left with k squared, which is useful further down. So we can write y equals a cos x plus a sine x in the form y equals k cos x minus alpha, k cos x plus alpha, k sine x minus alpha, and k sine x plus alpha. It's just addition formula we did a couple of weeks ago. So express 5 cos x plus 12 sine x in the form k cos x minus alpha. So doing the expansion with addition formula, k cos x minus alpha is k cos x cos alpha plus k sine x sine alpha. What we do is we flip it round, so we put the alphas at the front and the cos x and the sine x at the end. So we get k cos alpha cos x plus k sine alpha sine x. What we do is we line up what we've got here. So the 5 is with the cos x, so cos x, line up the cos x's. The sine x, we line up the sine x's. So we get plus 12 and 5. So k cos alpha is 5, k sine alpha is 12. Both of these are positive, so the only place where they're both positive is the first quadrant. So, from what we did further up, the square root of k squared sine squared alpha plus k squared cos squared alpha, we know is just k squared from above. So 12 squared add 5 squared. So 144 add 25 is 169. Square root of 169 is 13. For alpha, k sine alpha over k cos alpha is tan alpha. So tan alpha is 12 over 5. Because we know it's the first quadrant, just a straight inverse tan gives us 67.4. So 5 cos x plus 12 sine x is going to equal 13 cos x minus 67.4. So doing one that doesn't come out nicely to the first quadrant. So express negative cos x minus 4 sine x in the form k sine x minus alpha. A little bit different, we've got a sine x this time. So k sine x minus alpha is k sine x cos alpha minus k cos x sine alpha. Putting the alpha bits at the front, we've got k cos alpha sine x minus k sine alpha cos x. So the cos x had a negative 1 in the front, and the sine x had a negative 4 in the front. So we line up the sine x, we line up the cos x. So here, k cos alpha is negative 4. Here, k sine alpha, we've got a minus minus, is plus 1. So cos is negative, sine is positive. So the only place where cos is negative and sine is positive is the second quadrant. So we're looking for a second quadrant angle. So again, k is the square root, k squared sine squared alpha plus k squared cos squared alpha. So 1 squared plus negative 4 squared. So 1 add 16, which is root 17. Tan alpha is k sine alpha over k cos alpha. So tan alpha is 1 over negative 4. So again, we do our acute angle. So tan A is a quarter, so A is 14. Because it's second quadrant, alpha is 180 minus 14, which is 166. So negative 4 cos x minus 4 sine x equals root 17 sine x minus 166 degrees. You'll notice now double trig to a single trig ratio, which makes it really useful.